Hello and welcome to another SETI Live. This is part of a special series, special event we have going on called Nightmare on SETI Street. We are celebrating 13 days of spooky SETI. So we're going to look at all of the darker side of astronomy, planetary science, and even cosmology. With me here today is Dr. Katie Mack, who is a cosmologist who wrote the book, The End of Everything, Astrophysically Speaking. We've had her on the show before to talk about that book, and today we're going to have her share some of those spooky, scary stories about how the universe is going to end. So I'd like to welcome Dr. Katie Mack. Thank you for joining us today.
Thanks so much for having me. It's always fun to talk about the end of the universe.
So tell me, how did you? Oh, one sec. Everybody, don't forget to tell me where you're watching from. I will give shout outs in a little bit. So Dr. Katie, how did you get into cosmology? What motivated you? What inspired you to take this on as a field, in particular, the end of the universe side of things?
Well, so I've always been interested in big questions and how things work. And so when I first got into cosmology as an idea, it was when I was very young, and I was always sort of tinkering with things and trying to understand the building blocks of everything and the rules that govern everything. And then I started reading books by Stephen Hawking and people like that, and learning about the Big Bang and black holes and all of that. And I really wanted to dig into those big questions in cosmology, but I didn't really start thinking about the end of the universe very much until I was in undergrad. And there was this class that we had as physics undergrads at Caltech, where if we were taking the astronomy kind of side of things, we could go to the houses of the astronomy professors, and they would sort of give you dessert and tea and talk about their research. And this was kind of this fun little thing we did once a week. And one of my professors, Professor Stroll-Finney, was talking about cosmic inflation, which is this event that happened, we think probably happened in the very early universe, where the universe expanded very rapidly and sort of stretched out, and it sort of set up the conditions for what we think of as the hot Big Bang, the sort of primordial soup of the very early universe. And he was talking about the fact that, we didn't know why inflation happened. We had no idea if something like that could happen again, if the universe could suddenly start evolving in this really bizarre way. We had no idea, what set it off. So we couldn't say it wasn't going to happen, just right now. And he was telling this story, with his little toddler daughter sitting on his lap, very cheerful, kind of smiling. And I remember sitting there just being completely thrown by this idea that the universe has this cosmic evolution, these giant processes, these huge destructive or in some cases constructive things that go on that we just have no control over at all. We're totally at the mercy of these huge cosmic forces. And I remember just being really kind of blown away by this idea, and a little bit scared at the time. And as I've studied more cosmology, that feeling hasn't really gone away. I've discovered more ways, through my reading, I've learned more ways that the universe could end suddenly. and it's been interesting, but also, confronting to think of how small and powerless we are in this, vast cosmic ocean.
I definitely got a sense of sort of, cosmology is appropriately named. It is very on the cosmic scale of what you're looking at. As a planetary scientist, I'm looking at much, much smaller things that to me still seem very vast. But then you're looking at things on a scale that is really hard for the human brain to wrap around. So what has been sort of these maybe, let's start with, what's the scariest one in your mind? What's the scariest bit that you've learned?
The scariest possibility for the end of the universe, or the scariest thing in the universe?
What's the scariest thing in the universe?
Well, I mean, I think that okay, so I have a little anecdote that has nothing to do with the end of the universe, but is still really frightening because it has to do with the end of us as humans, right? Um, which is, the the sun is going to kill us eventually. Okay, the sun is very important to us. It provides the light and heat that we need to survive on this planet, but it's going through its own life cycle, and eventually the sun will start running low on the hydrogen that it's fusing to turn into helium, and it'll evolve. And one of the ways it evolves is it'll start sort of swelling and turning into a red giant, which is a much larger, cooler star, but also it'll be much bigger and brighter. And so it'll eventually boil off the oceans of the Earth. It'll envelop Mercury and Venus, and it may or may not envelop the Earth. We're not entirely sure how that's going to go, but in that process, it'll boil off the oceans of the Earth, and that'll take somewhere on the order of 1 billion years, maybe half that time, somewhere in there. And then it'll keep evolving as after it boils off the oceans of the Earth. That's fairly early in the process, and then whether or not it engulfs us is another question. And then it'll sort of slough off the outer layers, and it'll become a white dwarf star, which is a very compact, very hot sort of stellar remnant, just the core of the star. And it'll evolve, it'll sort of cool over billions and billions and billions of years. One of the things that's scary about that process is just the fact that we know that this is going on, and we can predict it. But the thing that I find really disconcerting about that is that we have seen evidence of this happening to other planets in other star systems. So we as astronomers can look at white dwarf stars, and look at the spectrum of those stars, which tells us about the chemical composition. And a large number of those white dwarf stars are what we call polluted, which means that they have heavy elements in their spectrum that wouldn't be there just from the star itself. And when we see those elements, we know that star has eaten a planet or two, right? And the first time I was in a discussion in an astronomy group, where this came up, when people were talking about polluted white dwarf spectra, I was just like, but that was a planet, like it ate its planet. And we're looking at just these little spectral lines that are all that's left of an entire planet. And there could have been people there, like we don't know, right? Like we don't know what might have been living on that planet before the star ate it. And that really brought it home to me as something that isn't just sort of theoretical stellar modeling, but this really happens in the universe. Stars eat their planets, and those planets, all that is left to remember them is a sort of temporary, spectral, spectral pollution, right? Like just there's a little bit of, there's an iron line, and there's some calcium or whatever. Like that's what's left of an entire world. And so I was in that discussion hearing about that, and I thought, one day our planet is going to be just a little bit of pollution in the spectrum of a white dwarf, possibly viewed by creatures on other worlds. And that I think was one of the most scary things that I've learned about astronomy. And that has nothing to do with the end of the universe. The end of the universe is much farther off, in some sense, much more violent than that. But that little anecdote really kind of struck home for me because it felt very personal.
Well, speaking of the planet, I want to give some shout outs to where people are watching from for a moment here. We have viewers in Scotland, Virginia, Guatemala, Florida, Portugal, Georgia in the US, Argentina, Seattle, Washington, Alabama, North Dakota, Pakistan, Oklahoma, Kentucky, Tennessee, here in California, Canada, the United Kingdom, Australia, Mexico, Chicago, Italy, wow, just everywhere, Brazil, Ohio, Indiana, West Virginia, Germany, wow, all over the world, everybody's watching from. And so you're getting a chance to scare a lot of people.
Okay.
So what do you think is you give in your book, you give 5 different ways that the universe could end.
Mhm.
What is the least scary to you? Let's start at the bottom of the list.
Okay. So I think the least scary is also the one that I think is probably the most likely, which is called the heat death. It's the least scary. It's also the least dramatic, but in some sense the most depressing. So the idea behind the heat death is that our universe is expanding, and what I mean by that is that galaxies are getting farther apart from each other. There's more and more space all the time. The universe is getting less dense in matter and radiation, and cooler and darker and emptier over time. And that process is just going to continue as far as we know. Based on our current understanding, the universe will continue getting emptier and emptier. Things will get farther and farther apart. Our galaxy is going to merge with the galaxies in our little local group of galaxies, Andromeda, Triangulum, these smaller satellite galaxies, in just a few billion years. But after that, our little clump of stuff will be alone in the universe for a very long time. So in 100 billion years, we will not be able to see other galaxies because they will be so far away from us that they will be effectively invisible. The light will be stretched out and they'll be moving away from us so quickly that we won't be able to see the light from these other galaxies anymore. And we'll be, sort of in this cold, dark, lonely universe as the stars fade away and everything kind of decays. Matter will decay and black holes will evaporate, and that just sets us up for this sort of slow fade into just the waste heat of everything that ever happened in the cosmos. And so it's a sad story, but it's not a scary story to me because it takes so long. It's trillions and trillions and trillions and trillions of years. And we have, a lot of time before even the stars all burn out. Like it'll be billions and trillions of years before we have to start worrying about not having starlight anymore. So it's, it's a very distant future one, and it gives us kind of the most time to work with, which is nice. So that, I think that's, I think it's one that makes people sad, but I don't think it's one that's really frightening in the same way as some of the others.
Okay, so that brings us to what's the next scariest for you?
I think maybe some of these like cyclic universes. So there's some ideas where the universe can end and then start again, or a new universe would come out of the ending of our universe, and some of those involve actually evolving to the heat death, to this end of universe, where everything's cold and dark and empty, where you can have a heat death and then you can have a new universe come out at the end of that. There are some where you'd have sort of some cosmic contraction and then a kind of new big bang would come out of that, and then you'd have a new universe out of that. I think that those are, so the one where the heat death comes first is no scarier than the normal heat death, because it's just, the heat death happens and then we're done and then something else might come afterward. The one where you have some contraction and then a new universe is a little scarier, because we wouldn't necessarily see that contraction coming, or like it would start to happen and then the universe would be kind of incinerated as the new big bang occurs. So that would be a little sudden, perhaps, and not fun. But there may be some consolation that a new universe would come after, and so maybe you could feel a little bit cheered by the fact that it won't be the end of everything; it'll just be the end of us and everything in our universe. So I think that one, if I had to choose sort of second place in terms of least scary, then I'd probably go with that one.
Okay. Let's see. I kind of feel like I want to go straight to the heart of it. What is the scariest one?
Okay, so it depends on whether you want to see it coming or not. Okay. So there are two possibilities.
I think not coming would probably be the scariest one, right?
Okay. So in that case, if you think it's scarier not to see it coming, and I don't know if I agree with that, because I think that watching the universe coming to an end would be deeply frightening. But if we want to go for like the unexpected, then you got to go with vacuum decay, which is my personal favorite end of the universe scenario, because vacuum decay is this process where there would be a kind of quantum event at a subatomic scale somewhere in the universe. It's technically it's a transition in the Higgs field, which is this energy field that pervades all of space and kind of determines how physics works in our universe. And there would be this quantum event, a quantum tunneling event. So just a little sort of shift in that energy field at one spot, and that would set off a chain reaction where it would create this bubble of a different kind of space, what's called a true vacuum. And this true vacuum bubble would expand out at about the speed of light. And because it expands at about the speed of light, you cannot see it coming, because, if something is moving toward you at the speed of light, then by the time the light from it reaches you, it has also reached you, right? So if this bubble is expanding at about the speed of light, you have no way of knowing that it's coming for you. And it's bad because the true vacuum state, the space inside this bubble, would have different laws of physics, and specifically unsurvivable laws of physics. That our atoms and molecules would not be able to hold together in this true vacuum space. And so as the bubble came for you, the wall of the bubble would probably incinerate you first, and then you'd be inside this bubble where none of your atoms and molecules could hold together anymore. And that just would destroy the whole universe. And then once you're inside the bubble, the space inside the bubble is also unstable. And so you would like collapse into a black hole as well. So it's a very complete, very violent kind of end. I think the bright side of it is that you wouldn't know that happened. You wouldn't feel it. You wouldn't see it coming. If it's coming at you at the speed of light, your nerve impulses don't travel that fast. So you wouldn't feel anything as it went by you. You wouldn't know that it went by you because you'd be destroyed before you could process anything. And everything else is destroyed too. So it's not like there's a tragic aftermath, nobody's going to miss you. It's just, the universe is just over. And so in that sense, it's fine. You don't even know it happened. On the other hand, I think that a lot of people are very disconcerted by this idea, because if it is governed by this quantum event, you can't predict it. You don't know when or where it might happen. We can put probabilities on it, and we can say that based on our understanding, it would be at least 10 to the power of 100 years before one of these bubbles is likely to appear in our region of space. On the other hand, we don't know for sure. I mean, that's just a probabilistic thing. It technically could happen sooner, but I don't want people to worry about this, because I do get emails from people saying that they're very, very scared of vacuum decay. It's not something to worry about. I mean, partially because obviously you don't even notice if it does happen. Like I feel like you shouldn't be worried about stuff like that. But the other thing is that that we don't know for sure that it could happen. And what we do know of it suggests that it's very unlikely to happen anytime between now and when our planet is destroyed and the sun dies and all of that. Like it's probably way down on the list of priorities in terms of threatening things in the world or in the universe. But I, as a physicist, I really enjoy the idea, because it's just such a weird thing, like that the universe could be destroyed by a tiny subatomic transition that we wouldn't be able to predict or see coming at all.
See, I think that's scary, but you're right. At the same time, like, you're not going to notice. It's just one of those things. It's like you wouldn't even have time to really enjoy the horror, right? I mean, it's just over.
No, it's just over.
And there's no way to see it coming. You can't see like artifacts in any place else. It's just.
Nope. No, I mean, in principle, if you could come up with something that could cause it, then you could potentially see that thing happening and then deduce that it could happen. But there's not even, as far as I know, there's nothing that could cause it. It's just, it would have to be this kind of random event. So So no, I think you're totally in the dark about it. I don't think there's a way to predict it. I mean, it might not even happen. Like our predictions about it depend on relying on a theory that we know is incomplete. So there are various reasons not to worry about it. There's a lot we're still trying to understand, but as a physicist, it's definitely fun to think about because it's so dramatic.
All right, but you have one more that we are going to see coming, and that's more horrifying for you. So, what's that one?
Yeah, there are two more, and you'd see both of those coming.
Oh no. Okay.
So so there's the big rip and there's the big crunch. I'll start with the big rip. The big rip is a scary one. We think it's very, very unlikely to happen. But the idea behind the big rip is that dark energy just kind of goes haywire. So dark energy is something that's making the universe expand faster. We know right now that the expansion of the universe is speeding up. And we think it might be due to something called a cosmological constant, which is just a property of space that it has this kind of stretchiness built in, and that would make it speed up over time. But it could be something else. And whatever it is that's causing the universe to speed up, we call it dark energy. And if it's a weird kind of dark energy that we call phantom dark energy, which we have reason to believe it probably can't be because theoretically there are kind of issues with the way the mathematics works, but if it could be this phantom dark energy, then the dark energy would get more powerful over time. So not only would it make the universe expand faster and faster, it would start to make objects in the universe expand. So right now, as far as we understand with dark energy, it can move things apart from each other. It can make more space in between things, but it can't build up within like a galaxy or a planet or this room. But if dark energy is phantom dark energy, then it will start tearing apart actual structures. So it would first start moving galaxies out of galaxy clusters, then it would start pulling stars out of galaxies, then it would start pulling planets away from their stars. The solar system would kind of stretch out and we'd lose the outer planets, and then the Earth would wander away from the sun. And then as time goes on, it would build up within the Earth, and it would sort of explode the Earth. And then it goes to smaller and smaller scales. So it starts pulling apart molecules and then atoms and then even nuclei, and just ripping everything apart and destroying the whole universe in the final moment. And that's called the Big Rip. And we think it probably can't happen. But we can also, based on our observations, say if it were going to happen, it would be at least about 200 billion years in the future. So we have time, but it's a scary one because you would see it coming. You would start to see things kind of pulling away from things, and you'd start to see galaxies unraveling and the outer planets wandering away, and the moon would go away, and you know that it's coming for you. So that's a particularly scary one. But my number one scariest one is called the Big Crunch. And that's the one that we also think probably won't happen. But if dark energy is something super weird, maybe instead of expanding the universe, it could turn around and start contracting it. We don't know for sure what dark energy is. But if the universe did start contracting instead of continuing the expansion, if the expansion stopped and it contracted again, then we'd be headed for a big crunch. And that's the one, they actually thought that it was likely in like the 60s. That was the one that was sort of the preferred, by the data, the preferred idea. Now we know more, we have better data. So we think it's unlikely because we see that the universe is expanding and accelerating in its expansion, but we also don't know what dark energy is. So, we can't say for sure. And it's not this weird thing that'll turn around. But what would happen with the Big Crunch is that the expansion would stop, and galaxies, instead of moving away from us, would start moving toward us. And so distant galaxies would start to rush toward us. They'd look blue as they're coming toward us. They get brighter. And, collisions between galaxies can be really dramatic, but not terribly dangerous for the planets because stars tend not to collide even in galaxy collisions. But what would be really bad in a collapsing universe is that it's not just the matter that gets compressed, but it's all the radiation in the universe that gets compressed. So, we know that in the early universe, the universe was full of hot plasma, because the universe was so dense and it was very hot and it was full of this roiling plasma like the inside of the sun. And then as the universe expanded, that kind of expanded and cooled, and that plasma cooled down, the fire kind of went out and it became just inert gas. If you're compressing, then you're going to come back toward that sort of hot plasma state. All of that that radiation, all that matter is going to start being compressed again. And all of the radiation that's been sort of floating around in the universe because of the expansion of that hot plasma, all that radiation is going to come back and be intensified. And then all the radiation from all of the stars that ever shone, all the light from the stars, the visible light, the ultraviolet light, X-rays from high energy astrophysics objects, gamma rays, all of that's going to be compressed, and it's going to be, that radiation is going to be hardened. It's going to get brighter. It's going to get more intense. It's going to get higher frequency, so harder radiation. And so it's been worked out that as you approach a big crunch, space gets so hot, the radiation environment in space gets so bright and intense and like high frequency, that you actually get to the point where the light of space itself starts causing thermonuclear explosions around the surfaces of stars. So space would be so hot it would start to explode stars from the outside in. And then the whole universe is just this hot roiling plasma. And that's the one that I find scariest, because I find it terrifying, the idea that you would see all of these galaxies rushing toward you, and you would see space just get hotter and hotter and brighter, and there's nowhere you can go. There's nothing you can do. You would just be waiting to get cooked. So that's the one that I find terrifying. Luckily, we think it's very unlikely, but it's a really intensely frightening end of universe possibility.
Wow. Okay. I'm going to be, I don't know about anybody else. I'm going to have some nightmares tonight. It's all good. That was the whole point. Thank you, Katie. That has left me with some more things to think about. A couple things. We're getting close to the end here, and I want to remind people that tonight, to continue sort of the theme of things that might scare you a little, we have a SETI talk on black holes with Laura Brenneman and Dan Wilkins. That is at 7 p.m. Pacific, 10 p.m. Eastern. If you haven't registered on Eventbrite, there is still time to do that. Otherwise, you'll be able to at least watch the stream on our various streaming services, and those links will be available later today. As well, next Thursday, continuing on our theme, my colleague Seth Shostak will be speaking with Dr. Phil Plait, who will talk about ways that the universe is actually trying to kill you. Katie's stuff is very, very scary, but it's not likely to happen in your lifetime. Phil talks about things that might actually happen in your lifetime. So if you want to come back and be scared again next week, that's another good time for that. And also, as a reminder, this is our special Nightmare on SETI Street event. We are giving away a free ebook. So if you want to see 10 of the scariest places in the universe, you can check out our website and go to our page and put in your email address and get that free ebook. It's pretty cool. There's some neat pictures in there, some great explanations of what's going on in them. And keep watching our social media over the next couple of weeks. We'll be sharing some more images out of other objects that are a little scary. So it's pretty exciting. There were a couple questions. So I know that most who deal with is cosmology, but is there any other way you can think of that the world would end suddenly that scares you?
I mean, I think that so the universe, the world, our planet will end when the sun gets too bright, in the sense that once the oceans are boiled off, you can't support life in any reasonable way on our planet. There are other things that could affect our planet that could be really awful, right? So major asteroid impacts could be extinction level events. That's something that is possible. There are a lot of people working really hard to monitor our environment in terms of the big scary space rocks, and our there's a whole planetary defense program that is trying to track everything and coming up with cool ideas for redirecting or destroying potentially hazardous objects. But if you had a big enough impact, that is certainly something that could could be a problem. And I'm sure that Phil Plait will talk next week about some other really scary things that could happen to our planet. So I don't want to give too many spoilers for that. But I do think about
just ask the dinosaurs, right?
Right.
Oh, wait,
right,
we
yeah.
can't.
Yeah. I mean, I do think about asteroid impacts sometimes. I mean, I know that it's not something that it makes sense to worry too much about, but we're just out there in space, and there are a lot of rocks out there. So
I have found that there's a common thread amongst most astronomers and planetary scientists that the universe is out to kill you. You just don't know how yet.
Yeah.
And there's only so many ways you can prevent it. As a planetary scientist, I'm always people often ask me, like, well, how do you feel about Yellowstone or any big giant caldera that could go off? And I'm like, I don't really think it's going to happen in my lifetime. I'm not really concerned about it on a day-to-day basis, but on a probabilistic basis, yeah, no, it's terrifying. Like it,
yeah.
But I still would want to be there to watch it.
Sure. I mean,
right? I mean, wouldn't you want to see any of these things happen, right? Like, if you could, you would love to be at the end of the universe.
For sure. Yeah, no, I mean, some of them there wouldn't be a whole lot to see, but I definitely I want to know what that would look like. I mean, I do my best in the book to talk about what you would see if you were there. But actually watching, watching space light up or watching the planets move away from the solar system, like that kind of thing would be fascinating.
Yeah, absolutely. I completely agree. Someone is asking, will a new universe be created after ours ends?
So it depends. We don't know for sure. There are some possibilities that do include a new universe coming out of the end of ours. So I mentioned a couple of those, where you could have a heat death that evolves to a new universe. That's an idea called conformal cyclic cosmology that's talked about by Roger Penrose and others. There's also this idea that you could have a kind of contraction that leads to a new Big Bang. That's the model that I talk about in the book is called the ekpyrotic cosmos, that my PhD advisor, Paul Steinhardt, was one of the people who started talking about that. So there are a few possibilities where you could have a new universe that kind of comes out of the ashes of our own. But there are also possibilities where there could have been sort of multiple universes created in the early times of our universe, or our universe could be, a universe that popped out of a much larger space that's been expanding and expanding, for who knows how long. And there could be a bunch of little pocket universes that have come out of that space. So, when our universe ends, in the sense of everything in our observable universe being destroyed, that doesn't necessarily mean that the entire multiverse has ended. Like, there could be other spaces where things continue, or where things are just getting started. So there are lots of possibilities for something carrying on after us, for sure.
So someone else is asking, was all the dark energy that causes our expansion rate already present in our universe at the Big Bang?
Yeah, that's a great question. So if the dark energy is this cosmological constant, that is just kind of a property of space, something that you can write into the equations of the evolution of the universe, then yeah, it's been here the whole time. And the reason that it's starting to, the reason it's making the universe speed up now, or in the last few billion years rather than the whole time, is that it only really becomes important when the universe gets big enough so that there's sort of kind of, in some sense, way more space than matter or whatever. And so when there's a whole lot of space, then that little bit of stretchiness of space can overcome, the kind of slowing down of the expansion that gravity causes. So in the early universe, when the universe is expanding, just because the Big Bang happened, it's expanding, but it's slowing, because as the galaxies are moving apart, they're also kind of pulling on each other with gravity, and that kind of slows down the expansion. So the universe was slowing in its expansion for a long time, but when everything got far enough apart that mutual attraction was not very strong anymore, and there was a whole lot of empty space in between, then the little bit of push that expansion that the cosmological constant gives space was able to overwhelm that slowing and make the universe expand faster and faster. So that's the story that we tell. That's what we think probably explains why the cosmological constant, if that's what dark energy is, has only become important in the last few billion years, whereas it's been part of space, has been a sort of property of the universe since the beginning, as far as we know. But there are other possibilities for dark energy where it somehow changes over time, where maybe it only really became important recently, or came into effect recently. So we're not entirely sure of that.
So what's the biggest mystery that you are looking to solve in, say, like the next 5 to 10 years?
Well, the mystery that I work on in my research primarily is the mystery of dark matter. So dark energy is something that makes the universe expand faster. Dark matter is a kind of matter. So matter is something that has mass, it has gravity, it kind of pulls together. We are made of matter, but there's another kind of matter, dark matter, which is invisible and untouchable, and it kind of it's most of the matter in the universe. So when you see a galaxy and it looks like a kind of disk of stars and stuff like that, you have to imagine that that's embedded in this giant clump of this invisible matter, and that giant clump of matter is kind of holding all of the regular matter inside that galaxy. And so we have reason to believe that the vast majority of the matter in the universe, something like 85% of the matter in the universe, is this invisible stuff, this dark matter. We have lots of good reasons to believe that it's there. There are lots of observations that give us a really good hint that this stuff is out there and that it's most of the matter in the universe, but we don't know what it's made of because we can't see it, and because we've never been able to catch it in a laboratory experiment. We don't know if maybe it's a new kind of particle, but we don't know what kind of particle it is. So we're trying to figure out what that dark matter is made of. How it came into existence, what its properties are. And that's a really big mystery. And that's what I'm particularly interested in my research. And it's a fun thing to work on because we kind of know where the dark matter is. We kind of know what it's doing. We just don't know what it's made of.
All right. Well, when you finally figure that out, you are going to be back here and you're probably going to be
Sure.
sharing your Nobel Prize with us. So good luck on all of that. Obviously, that is fantastic. So where can people find you on the internet?
Well, you can find me, you can find information on my website, which is astrokatie.com. There's information there about my book and about various things I've written and talks, and a little bit about my research. And then I'm on Twitter as astrokatie. So you can find me there pretty often. I talk about science. I also talk about various things that I care about in the world. So it's not pure science, but I do discuss a lot of physics and astronomy there. On Instagram, I am Astrokatie Mack, because the name Astrokatie was taken on Instagram when I joined. But I do occasionally post stuff on Instagram. And on Facebook, I'm at facebook.com/astrokatie, although I very rarely do things there. And on TikTok, I have a few videos up about the expanding universe on TikTok. And there you can find me as Astrokatie Mack on TikTok. I think it's Astrokatie Mack on TikTok. Look it up.
That
You'll
is,
see. It'll, yeah.
So you're everywhere. Yay!
Yeah, I'm pretty much everywhere.
All right. Well, Katie, thank you so much for joining us today. It is a pleasure as always, and I'm a little more terrified. Just, I don't know. Wow. Okay, things to think about. So send your questions to Katie, and we will be seeing you guys again tonight. So come back for our SETI Talk event tonight. We'll have that link up a little bit later today. You can still register for the Eventbrite. We should have that link in our comments. And or you can check out our website on our events page. So go to SETI.org and you can see all of that. And once again, we are a 501c3 nonprofit. So we are always looking for donations to keep our programs running, from our research to our outreach. We don't get as much government funding as everybody seems to think. So if you want to come help participate and make this keep going, that's how you have to do it. And we always appreciate your stars on Facebook, your bits on Twitch, and your super chats on YouTube. It's always a pleasure. We're very appreciative. So thank you, everybody, for watching today. Thank you, everybody, for joining us. And I hope you're all walking away a little bit more informed and maybe a little bit scared. And we'll continue to scare you with some fun science over the next few days. So thank you, everybody. And again, thank you, Katie.
Thanks so much for having me. This was a lot of fun, and thanks everyone for attending. And I hope you're not too terrified. It was fun.
All right. Bye.